How does entropy explain the universe's heat death? Imagine a universe where everything is perfectly ordered, with stars shining brightly and galaxies clustered tightly. Now picture that universe slowly losing its structure, becoming more and more disorganized over time. That's where entropy comes into play. Entropy is a measure of disorder or randomness in a system. It tells us how spread out or mixed up energy and matter are. In thermodynamics, it also relates to the amount of thermal energy that cannot be used to do work. The second law of thermodynamics states that in an isolated system, entropy always tends to increase. This means things naturally move toward more disorder, not less. Now the idea of heat death comes from this law. It suggests that over an extremely long period, the universe will reach a state where everything is evenly spread out. All the energy will be distributed equally, and there will be no differences in temperature or energy gradients. Without these differences, no work can be done. No chemical reactions, no movement, no life. It's like a room that starts messy but eventually becomes perfectly uniform, with no way to clean or change it anymore. As the universe expands, it cools down because energy becomes less concentrated. Stars burn out, galaxies drift apart, and matter becomes more dispersed. This process increases entropy because the organized structures break down into a more uniform, less energetic state. Think of it like ice melting into water. The structured solid turns into a more random liquid. Over billions of years, black holes will evaporate through a process called Hawking radiation, releasing their energy slowly into space. All these processes contribute to the overall increase in entropy. Eventually, the universe will reach a point where all energy is evenly spread, and nothing can change or do work anymore. This is the heat death scenario. It's a very slow process, taking trillions of years or more. In this state, life as we know it would be impossible because there would be no energy differences to power any activity. The universe would be a cold, quiet, uniform expanse. Understanding entropy helps us see why this happens. It's a fundamental principle that governs everything from tiny chemical reactions to the grand evolution of the cosmos. The universe's journey toward maximum entropy explains why it will eventually become a vast, featureless space with no activity or life. It's a natural outcome of how disorder and energy dispersal work on the largest scales.